Hi, welcome to the OCR 21st Century Science series of videos for pupils at Sawston Village College. This video is about how to ensure that you get the maximum marks in controlled assessment, specifically data analysis. So, OCR 21st Century, and we're looking at data analysis. Now, in data analysis, there are 4 strands. Strand D, which is about planning. Strand E, which is about your graph representing your data. Strand F, which is about evaluating of your data. And strand G, which is to review the hypothesis. So, at the start, you will be given a hypothesis to test. Now, a hypothesis is a testable statement, and it's deliberately vague. For example, it might say that the voltage applied to a bulb affects its brightness. So, e.g., voltage affects brightness. Now, I'll emphasize the vagueness here because that hypothesis, which you're going to test, does not tell you whether the voltage makes the bulb brighter or dimmer. It just says its effects. So this is deliberately vague because what you've got to discover is, does the voltage increase the brightness or does it decrease the brightness? So bear that in mind at all times. Make sure that you realise the initial hypothesis is quite vague and your job is to refine that hypothesis. So at the start you will be given a document that looks just like this. This is your checklist and you see it's got strand D, E, F and G upon it. So we're going to start by looking at strand D and how you get good marks on strand D. Strand D is the planning section. So how do we make sure we get the best marks on planning? So here is that section blown up. It's already ticked because I've done this video once and bodged it up. So first thing you need is a fully described method. And I think this is the easiest thing to do. A method is something you've done lots of times. A method is simply, if you like, a recipe of instructions to follow. And you want to give a level of detail that somebody else could do your experiment just from your piece of paper. So if you gave them your method, could they follow that method and could they do exactly what you did in your experiment? That's the aim. So that's quite straightforward. Repeats basically means that you need to include in your plan that you're going to repeat each measurement. Now, it's really crucial to repeat each measurement simply because, for example, if I took 2 measurements only, those 2 are quite different. It's not till I take the 3rd measurement that I realise that those 2 are very similar or concordant. This one might be an outlier. So we always plan to do repeats. If we don't repeat results, we can't tell if the one result we got might have been the outlier. In this case, the first result looks like an outlier because it's way different to the other 2. But you don't know it's an outlier until you've repeated it. So don't forget to include repeats in your plan. Next thing you need is an equipment list. So an equipment list simply means, what did you use? And it can just be a list of bullet points. So, Bunsen burner, 30 centimetre ruler, 100 centimetre cubed beaker, etc. So that's just your list of stuff. Now, the trickier parts are these 2 bits that I've underlined in red. These are justifying. Now, justifying your apparatus means giving the reason that you chose it. Okay, so you've got to justify your equipment. And I would like you to make sure that you keep your justifications in this kind of format. So equipment justification, you can write it with the equipment list. So you could write Bunsen burner and then give your justification underneath, or you could do your list and then you could do your equipment justification as a separate entity. It's really up to you. And I'll show you a couple of other pupils in a second. So equipment justification, try and get into the habit of saying, I chose this thing instead of this thing, instead of because, and for whatever reason. Okay, so for example, here is a justification. I used a Bunsen burner instead of a kettle to heat the water because I wanted to heat the water slowly. Now, I used this instead of this because, and that's really what you need to be thinking about. You need to say why you chose it as opposed to something else. It needs to be a positive choice that you've made and an explanation of why you've made that choice. So that's the equipment justification dealt with. Let me show you someone else's equipment justification. So you can see here this pupil, to give you an idea of the level of detail. They've got here equipment list with the justification afterwards. So equipment, justification, equipment, justification, equipment, and justification. One paragraph for each. So range of values justification. Well, you are planning the investigation. It's your choices. You chose your equipment and now you're going to choose your range. For example, if you are measuring the light intensity from a light bulb, so here's my light bulb, and you're using a light meter to do that, or a solar panel, so here's my solar panel, you decide how far away you're going to do these distances. Where are you going to begin and how far are you going to go? What will be your biggest distance and what will be your shortest distance? And that is entirely up to you, but there are some logical reasons. For example, if we take the distance of this solar panel from this light, well, clearly the shortest distance you can have is 0. So you can have it right next to the light bulb. The longest distance away might be limited by the fact that you've only got a certain amount of room, or it might be that the brightness was too low beyond a certain value. So beyond 2 meters, for example, when you did a little preliminary trial, you found that 2 meters beyond there was no reading anyway, so that became your maximum. So think about when you're justifying your range, you're thinking about what's my minimum and what's my maximum and why did I make those choices. And we want to avoid things like saying because it was the easiest or the most straightforward. Think of good scientific reasons why you've chosen those. So for example, with this solar panel, we've got our maximum because beyond 2 meters I discovered in my preliminary trial it didn't make much difference, and 0 was the closest I could get anyway. So that gives you your range. You also want to justify how many results you took. So how many distances should I do between my minimum and my maximum? 1, 2, 3, 4, 10, 50, 100? It's really up to you. But what the reasoning behind your choice should be based on is you want to get as many different distances as possible, so as many results as possible, but bear in mind you've only got 1 hour. And the reason you want as many results as possible is because you want enough results to see a clear pattern. The more results you have, the more obvious it is that what the pattern in your results is. So I would aim for a minimum of 7 results. Ideally 10 or more if you can, but if you aim for 7, I think 7 should be doable. Remember, if you're doing 7 results times 3 repeats, that's 21 readings you've got to take in 1 hour. That includes setting up, getting in, etc, etc. So be realistic. Obviously 100 results will be great, but it's totally impractical in terms of the time available. So that's what we mean by justification of the range of values. What's my smallest, what's my biggest, and why did I make that choice? Last thing is the risk assessment. So the risk assessment is you thinking about all of the possible hazards in your experiment. What could cause you harm in your experiment? What do you have to do to avoid injuring yourself in that experiment? So these student safety sheets come in really useful. In the student safety sheets there is already, for example, topics such as how to handle hot liquids, how to handle flammable liquids. So ask for one of these, useful vocabulary in here, and obviously the index. So ask for one of those in the lesson. And your risk assessment can look in different ways. Here is the risk assessment standard sheet that we give you. In this section you identify the name of the risk. In this section you describe what you're going to do to control that risk or to reduce that risk as much as possible. Ultimately your risk should end up being low once you've put in place your control measures. If your control measures don't make your risk low, then you need to think of a new control measure, because the experiment then will be too dangerous. And you can see that they've mentioned various things. This is a different investigation, but again you will make sure that you are dealing with all the risks that are possibly involved in your experiment. Doesn't have to be in that format. You could write it as a series of paragraphs. It depends on the danger levels in your experiment. Anyway, that brings us to the end of this first section. Make sure you've got a full method, you've repeated your results, a list of equipment, you justify why you chose your equipment, you justify your range of values, and you complete a full risk assessment. Okay, next video we're going to look at strand E, which is the graph.